digital service delivery. Citizens can access government services and information online, reducing the need for physical visits to government offices. And e-participation. ICT tools enable citizens to participate in governance by providing feedback, contributing ideas, and engaging in decision making. Government to government G2G interaction. ICT facilitates communication and data sharing between different government agencies for more efficient operations. Then open data initiatives. Open data initiatives involve making government data available to the public in a machine-readable format. It promotes transparency and encourages data-driven innovation. Key concepts: data portals. Government often create online portals to provide access to data sets, reports, and information. Then data privacy. Balancing open data with privacy concerns is a challenge. Anonymization and data protection measures are crucial. Then data identity systems. Definition: digital identity systems provide individuals with a secure and verifiable way to access government services online. They typically involve the issuance of digital IDs or EID cards. Digital identity systems provide security and reduce identity fraud. They simplify access to government services and reduce administrative burdens. ICT in service delivery. Online services. ICT enables the delivery of various government services online, such as tax filing, permit applications, and social welfare programs. Then telemedicine. Government use ICT to provide remote healthcare services, especially in underserved areas. Data analytics and decision support. Definition: governments use data analysts to governments use ICT to provide remote healthcare services, especially in underserved areas. Then data analytics and decision support. Definition: governments use data analytics to gain insights from large data sets. Decision support systems assist in policy planning and decision making. Applications: predictive analytics can be used to forecast disease outbreaks or traffic congestion. Then decision support systems aid in resource allocation and policy formulation. Then cybersecurity and data protection. With the increased use of ICT, governments must focus on cybersecurity and data protection to safeguard sensitive information. Then regulations and compliance. Governments enact regulations and compliance measures to protect data and prevent cyber threats. Challenges: digital divide. Not all citizens have equal access to ICT, leading to potential inequalities in service delivery. Then data privacy concerns. Protecting citizen data is paramount, but balancing it with open data initiatives can be challenging. Then cybersecurity threats. Governments must be vigilant in protecting their systems and infrastructure from cyber attacks. ICT and governance are tightly interwoven, offering the potential for more efficient, transparent, and citizen-centric government operations. This transformation is particularly relevant. Then next topic we learned: climate change and its socio-economic and political dimensions. Climate change, socio-economic and political dimensions. Climate change is a multi-faceted global challenge with profound socio-economic and political implications. Causes of climate change: greenhouse gas emissions. The burning of fossil fuels like coal, oil, and natural gas and deforestation release greenhouse gases like carbon dioxide into the atmosphere, trapping heat and causing global warming. Land use changes. Changes in land use, including urbanization and agriculture expansion, impact local climate patterns. Then industrial processes. Industrial activities emit pollutants and waste that contribute to climate change. Agricultural practices, including methane emissions from livestock and rice cultivation, release potent greenhouse gases. Deforestation. The clearing of forests reduce carbon sinks, increasing CO2 concentrations. Socio-economic dimensions. Human health. Climate change leads to extreme weather events affecting human health through heat-related illnesses, vector-borne diseases, and food insecurity. Then food security. Climate change disrupts agricultural systems, impacting food production and distribution, and can lead to food shortage and price spikes. Migration. Climate-induced environmental changes can displace populations, leading to climate refugees and conflict over resources. An economic impact. Climate change affects industries like agriculture, tourism, and insurance, resulting in economic losses. Then social equity. Vulnerable communities, often in developing nations, are disproportionately affected by climate change, exacerbating social inequalities. Then, political dimensions, international agreements. The Paris Agreement, signed by numerous countries, sets targets to limit global warming and reduce emissions. The national policies, government implement policies to reduce emissions, adapt to climate impacts, and transition to renewable energy sources. Then climate diplomacy. Climate change is a key topic in international diplomacy, with nations negotiating on emission reduction targets and climate financing. Then technological innovation. Political support is crucial for fostering innovation in renewable energy and sustainable practices. Climate activism. Civil society plays a significant role in advocating for climate action and holding governments accountable. Mitigation and adaptation. Mitigation. Mitigation strategies aim to reduce emissions, such as transitioning to renewable energy sources and implementing energy efficient measures. Adaptation measures focus on preparing for and managing the impacts of climate change, such as building resilient infrastructure and developing early warning systems. Then, climate finance. Financial mechanisms provide support to developing countries for both mitigation and adaptation, efforts. Understanding the socio-economic and political dimensions of climate change is crucial. Then, impacts of pollutants on human health. Pollution resulting from various sources poses significant risks to human health. Understanding the impacts of different pollutants, their sources, and mitigation strategies. Types of pollutants. Air pollutants. Air pollutants such as particulate matter, ground level ozone, carbon monoxide, sulfur dioxide, and nitrogen oxides are released from industrial processes, vehicular emissions, and other sources. Then, water pollutants. Water pollutants include chemicals, heavy metals, pathogens, and nutrients from industrial discharges, agricultural runoff, and municipal wastewater. Then, soil pollutants. Soil pollutants, including heavy metals, pesticides, and industrial chemicals, result from improper waste disposal, agricultural practices, and industrial activities. Then, noise pollution. Noise pollution generated by traffic, industrial process, and recreational activities affects mental and physical health. Then, health impacts of pollutants. Respiratory problems. Air pollutants can lead to respiratory issues like asthma, bronchitis, and chronic obstructive pulmonary disease or COPD. Then, cardiovascular diseases. Air pollution is associated with heart problems, including heart attacks and hypertension. Cancer. Exposure to various pollutants such as carcinogenic chemicals and radon gas can increase the risk of cancer. Then, neurological effects. Lead exposure from soil and water pollution can lead to developmental issues in children. And waterborne diseases. Waterborne pathogens due to water pollution can cause diseases like cholera, dysentery, and hepatitis. Then, developmental and reproductive effects. Certain pollutants like endocrine disrupting chemicals can affect fetal development and reproductive health. Food contamination. Pollutants in food such as heavy metals and pesticides can lead to foodborne illness and long-term health issue. Then, mental health. Noise pollution is linked to stress, anxiety, and sleep disturbances affecting mental well-being. Then, vulnerable populations. Children are more vulnerable to environmental pollutants due to their developing bodies and higher exposure risk. Elderly. The elderly may be more susceptible to health problems exacerbated by pollution. Low-income communities. Socioeconomically disadvantaged communities often face higher pollution exposure and fewer resources for healthcare. Then, mitigation and control. Pollution prevention. Reducing pollution at the source through cleaner technologies and responsible waste disposal. Regulation and standards. Enforcing stringent environmental regulations to limit emissions and discharges. Then, environmental monitoring. Continuously monitoring air and water quality to identify pollution sources. Public awareness. Educating the public about the health risks of pollution and promoting sustainable practices. Understanding the impacts of pollutants on human health is important. The natural and energy sources. Solar, wind, soil, hydro, and geothermal biomass, along with nuclear and forests. Natural and energy resources play a vital role in sustaining human civilization, supporting economic development. First, solar energy types. Solar energy can be harnessed through photovoltaic cells, solar panels. to produce electricity, and solar thermal systems to heat water or air. Importance: solar energy is abundant, renewable, and clean energy source, reducing greenhouse gas emissions and dependence on fossil fuels. Then sustainability: solar power is a sustainable energy source with a minimal environmental impact, but it requires technological advancements for efficacy and storage. Then wind energy: wind energy is generated through mild turbines that convert kinetic energy into electricity. Importance: wind power is a renewable energy source, reduces carbon emissions, and offers energy independence. Then sustainability: wind energy is sustainable, but the location and visual impact of turbines need careful consideration. Soil as a resource: soil includes various types such as clay, slit, sand, and loam, each with specific properties. And important: soil is essential for agriculture, providing a medium for plant growth and supporting terrestrial ecosystems. Then sustainability: sustainable oil management practices are crucial to prevent erosion, degradation, and nutrient depletion. Hydroelectric power: hydroelectric power is generated by harnessing the energy of flowing water such as rivers and dams. Hydroelectricity is a renewable and reliable source of energy, providing electricity and controlling flooding. Sustainability: hydroelectric power is sustainable but may impact local ecosystems and require careful environmental management. Geothermal energy: geothermal energy is produced by tapping into heat from Earth's core. Geothermal energy is clean and renewable source, providing heating and electricity. Sustainability: geothermal energy is sustainable but geographically limited and may cause subsurface resource depletion. That is geothermal energy. Then biomass energy. Biomass energy is derived from organic materials like wood, crop residues, and animal waste. Then geothermal energy is clean, produced by tapping into heat from the earth core. Okay. Then sustainability: geothermal energy is sustainable but geographically limited. Biomass energy is derived from organic materials like wood, crop residues, and animal waste. Importance: biomass is a renewable energy source, reducing waste, providing fuel, and lowering greenhouse gas emissions. Then sustainability: biomass energy is sustainable but must consider resource replenishment and emissions. Nuclear energy is generated by fission reactions in nuclear reactors. Nuclear power provides large-scale electricity generation with low greenhouse gas emissions. Sustainability: nuclear energy has low direct emissions but faces challenges related to nuclear waste disposal and safety. Forests. Forests encompass various types including tropical rainforest, temperate rainforest, and boreal forest. Forests provide habitat, clean air, timber, and carbon sequestration, playing a vital role in maintaining biodiversity. Then sustainability. Sustainable forest management is critical to prevent deforestation and protect biodiversity. Then natural hazards, mitigation strategies. Natural hazards and disasters are recurring events with potentially devastating consequences for human life, property, and environment. For example, geological hazards. Geological hazards include earthquakes, volcanic eruptions, tsunamis, and landslides. Meteorological hazards. Meteorological hazards comprise hurricanes, tornadoes, cyclones, floods, and droughts. Hydrological hazards involve river and coastal flooding, harsh flash floods, and ice storms. Then climatological hazards. Climatological hazards include extreme temperature, heat waves, and cold waves. And biological hazards consist of epidemics, pandemics, and vector-borne diseases. Then impacts of natural disasters: loss of life, loss of human lives, particularly in densely populated areas. Then property damage. Disasters cause significant damage to infrastructure, homes, and public facilities. Then environmental damage. Economic consequences: displacement, food and water scarcity, mitigation strategies, early warning systems, land use planning, building code, enforce strict building codes. Then disaster preparedness and response, climate change adaptation, deforestation, and erosion control. Then infrastructure resilience, public awareness and education, international cooperation. So significance: understanding the types of natural hazards, their impacts, and mitigation strategies is crucial for academics, policymakers, and examination candidates.